256 combinations, of course. So this is the visualization tool that you get with Lurk. It's called X-Mode 2, and what it does is it just draws you a picture of the modulation of the carrier frequency that's used in infrared. So with my garage controller, I set a bunch of different switch settings and then blasted it at X-Mode 2, and these are the patterns that came out. So here, when all the switches were on, I get a bunch of long pulses. When they're all off, I get a bunch of short pulses. When number 8 is on, I get one long pulse here, and so on. So it was clear that what was happening is we've got an 8-bit data pattern here, a start bit, and some stop bits. Very simple. So you learn those codes with Lurk, and what you get is a text file which has some timing information in it. This is to do with the timings of the ones and the zeros, which you don't particularly care about. And these are the actual codes that I learned. And as we can see, 0 is 0, all on is FF. So it's basically just a hex representation of the 8-bit code. So I write a little Perl script that spits out every possible code, paste that into the config file, write another little script that spits out each code, and it then took 54 seconds to send all possible codes. So here I am in my underground garage, fire up my laptop, start it going, and hey presto, the door opens. Now this wasn't really a big surprise because I knew I had the right code. You know, I had learned it already. I mean, I did go through the exercise and brute force it, and the door popped open, but strangely it popped open, the real code was like E5 or something, so it should have popped open towards the end of the sequence. What actually happened is it popped open in the first 10 seconds. So at first I thought, okay, there's like a backdoor code in here. The manufacturer has got a code that always works, so he has a master remote, and that's going to be really useful. Actually, no, it turned out that the guys who run this garage, this is a shared underground garage, they had gone to get some more remotes, and the company that supplied them had gone out of business. So they'd found another company who came along and went, ooh, yeah, difficult job this one, Gov, we'll have to put in a whole parallel system. So if you look here, they've actually got 2 receivers. And what they're doing is they've got 2 completely compatible systems and bolted them together so they both control the same door, when all they had to do was get the dip switches right on the new receivers, or the new senders. So if they'd had my tools, of course, they would have known this, but they didn't. And the other thing to note in this picture, all you security-minded people, sorry, come on one, will have spotted the camera there. So obviously, if I'm mucking about in a garage with a laptop and doors are opening and closing and I'm messing around and there's a camera watching me, what's going to happen? I'm going to get arrested, right? No, not a thing. Nobody mentioned it. So, you know, if you're going to put cameras in your places, watch the pictures. Yeah, see what people are doing. It's probably not good. Okay, so that was a really simple case, garage door opener. So I then wondered, well, can I apply that to hotel TV systems? In hotel TVs, they tend to apply this inverted security model. So the TV is controlling what channels I can watch. So maybe I could brute force the codes, tell the TV to open up some more channels. And you know, the suspicion was that the hotel was broadcasting all the content, the TV's filtering the content, that I didn't need any authentication to get into the system and change the commands and so on. And it wouldn't be encrypted. And the reason it wouldn't be encrypted is because it's a closed system. They don't need to encrypt it. They control the whole thing from end to end. So why would they need to encrypt it? And the way we can tell if they really are broadcasting the system is we could take our own TV in and plug it in and tune all the channels in and have a look. But that tends to raise a bit of suspicion when you're standing at the check-in desk with a Philips under your arm. So I carry one of these instead, which is a little USB TV tuner. Sure enough, if I plug it in, some of you may recognize this TV if you're staying nearby. So here's the TV showing the hotel system main menu, and here's my laptop showing another channel. And I scan through the various channels. And there's another one. And another one. And this one puzzled me for a while because it appears to be an advert for the company that are providing the back-end system. But nobody's ever going to see it. If you went through all the possible channels on this TV, you would never see that screen. And I couldn't understand why they would bother transmitting an advert. It actually became clear later this wasn't an advert, this is a screensaver. And on the screensaver is a very useful piece of information. It's the URL of the company that installed the system. So you go to that website and have a look, and there are data sheets for the system, tells you all the capabilities of what this thing can do, the hotels they've installed it in, the new features they're working on, which hotels have those features. So you can look at it and say, oh, interesting, credit card system, I might go and stay at that hotel. Or one of them, they're deploying webcams. Why would you want a webcam in your hotel room? I think I can guess. Could be a whole subject of another talk. And of course, they're broadcasting premium content. So this is a movie that I should be paying for, and here it is being broadcast on the system. Does anyone tell me what film that is? School of Rock, yeah. So, and if you're feeling really cheeky, you can feed that back through the SCART and watch it on the TV as it was originally intended. So. Okay, so very interesting. We've now proved that they're broadcasting stuff, but we haven't actually done anything to the TV. We haven't taken control of it. So I started looking at the codes, the infrared codes that the TV remotes were sending. And it turns out they're much more complex, a lot more bits involved. And the main reason for that is there's a lot of manufacturers using identical technology, so they don't want to be switching each other's devices randomly. So when you've got a Sony TV and a JVC video, you don't want power off for one of them to switch the other one off. So they have a manufacturer ID code on the front. They tend to use grouping, so they have another few bits which says this is a standard code, like a channel select or a up, down, left, right command. They have extra groups that only appear on hotel remotes, so like alarms and checkout buttons, and some interesting hidden ones, which is what we're looking for, of course. So this is the visualization. And as you can see, it's a much longer code than the garage door one. But this is where I think the visualization stuff comes in really useful, because at a glance you can see that most of that, if you looked at it as a hex number, it would be a bunch of really horrible hex numbers. But with the visualization, you can see that most of it's the same. So we only really care about this end bit. So the front is not changing, the last few bits are changing. Okay, but even so, we've got a 14-bit code which gives us 16,000 possible codes. Now, unlike the garage door, where you're just waiting for something to happen, you're waiting for the garage door to open. With TV codes, you're waiting for something to happen which may only produce a momentary result. So if you're not observing it when it happens, it'll be gone. The next code may cancel it out, it may just time out. So you do actually have to observe every single code that you send and see what happens. And I worked out it takes about 2 seconds per code, so that's 9 hours to test the whole lot. And I mean, obviously I am a sad geek and I don't get out enough, but even I draw the line at watching a TV for 9 hours for something that's going to happen, maybe. So I had to come up with a way of reducing the search space. So basically I recorded all the codes that were available to me in the hotel room. So I send all the commands 0 to 9, and I look at the bit pattern. So in this case, this is the code that's being recorded in the human-readable lurk config file. So we've used the first 2 bits, and then gradually as we go through the sequence, we start using these bits. So go through the whole lot, power, mute, volume, so on, And I've sorted these so that we're building up a picture of what bits are changing. Finally, we get to the end, and I've seen all these bits change, and I've seen these 2 bits change. These 4, I've never seen what they do. So my assumption is the first 2 bits are definitely used, 4 bits are unknown, and the main code is in the last 8 bits. So now I want to try and knock out some of those. I mean, clearly the last 8 bits I'm going to be having to test each of those because that's the main code, but maybe I can get rid of some of these. So I take my original command, in this case power, and for each bit of the ones I want to test, I toggle it. So if it was a 1, I set it to a 0. If it was a 0, I set it to a 1. And I retransmit that command. If it succeeds, then I can be pretty sure that that bit's ignored. I don't care about it. I don't need to test it. So when I've done that for all the possible bits, I got to the end, and I had 10 bits I actually care about, which gives me 1,000 codes, which is 2,000 seconds, about half an hour. I can live with that. That's fine. So I wrote a new config, which has the 8 bits on the end, plus 4 different lead-ins. I mean, I could have done this with 14-bit Perl code. If you know how to do that, please don't tell me. I really don't want to know. It's probably very evil. And then you just send all of those codes. And sure enough, I found a bunch of interesting things, which I've labeled. Some of them are engineering codes. Some of them are what I call housekeeping codes. And this is the one you really want, the God code. So the kind of codes that you find are housekeeping codes. So these are things that are done on a routine basis by the cleaning staff, for example, or the people who are replenishing the minibar. So they carry around in their apron, they'll have a remote which has these extra commands on it. The engineers who set up the rooms or debug or troubleshoot problems will have a different remote that has a bunch of other stuff that they can do. So these are the debugging codes and so on. And there are some services you can switch on or off with a button on the remote. So now I've got my new capabilities. What can I do? Well, I can change messages on the TV. I can assign the TV so it thinks it's in another room. I can assign channels that are now free, that didn't used to be. And I can find channels that actually don't even exist, like the one with the screensaver on it. So, first thing every good hacker has to do, obviously, is tag the thing that they've owned. So, there we are. This is what will come on in a particular room in a particular hotel in Las Vegas. And if you can tell me which room it is, I'll give you a system. I think, as far as I know, it still does that. So. Same thing in Amsterdam. Or you can actually change the whole message that comes up when you power the TV on. So it's not just the channel identity, it's the whole thing. And you can even lock the thing and really own it. So. I'll try and give a shout out to whatever conference I'm speaking at. So. More of the same. I'm not going to tell you where I was. Okay, so one of the other things you can do that's pretty cool is change the channel filtering. Now with most, particularly in America, most of the content goes out with electronic kind of tags on it saying what kind of program it is. So potentially you can filter what the TV will allow and what it won't allow. So here we have a system where they've rated the movies from G through to not rated and X and so on. But as you can see, this has been left dangerously wide open. I mean, anything could come into my room. It's been totally left open, and I felt I had to take matters into my own hands. So now only the good stuff comes into my room. So. None of that sport or news crap. So. Okay, so what else could you do? You can view the back-end systems. So here we have a test channel. Not very interesting. Actually, it turns out to be